All right, let's start with 3.7 and polynomial theory. Part 2, part deuce. All right, so let's kind of remind ourselves why we're doing all this. Because Pima made you, right? And because you want a degree. But why are we doing this? So the problem is, whenever you have a polynomial, I don't know, you're trying to say, when am I going to have, when is this, missile going to be 35 feet in the air? When is the number of kids you have going to be 35? I don't know, whatever the number is. You can always just subtract everything to one hand, you can always have, you can basically, if you're ever trying to solve an equation, this is what an equation is, right? It's a left-hand side and a right-hand side. You can always just subtract and then find zeros, right? So finding zeros is the name of the game. Finding zeros is the same as factoring. Finding zeros is the same as finding the x-intercepts. It's the same as everything, right? So when we factor, we're actually finding zeros. The reason we find zeros, because every problem can turn into a zero problem. That is the reason why we do all this. So, so that's that. So let's start out with another conjugate zeros theorem. So conjugate zeros theorem means if you take this class, then your next set of kids is going to be twins, conjugate twins. So I don't mean to curse you all, but you guys are like, I'm never having kids now. Actually triplets, so I should change that. You guys are like, I'm still hungover from spring break. So conjugate zeros, basically if z equals a plus bi is a zero of p of x, then so is, oops, this one doesn't have a bar above it. Still thinking of the bar. This one is bar, z bar. So what you do is you get basically two zeros for the price of one. But if you call within the next 15 minutes, I'll throw in another zero. Just pay for shipping and handling. You guys know how that scam works?
Yeah.
It's like the shipping is like 15 bucks, right? And you think it's free, but okay. So remember, their goal is to find zeros. So when you find a complex zero, you actually found two zeros. That's kind of cool. You guys got this? You guys remember why we're doing this, finding zeros now? Because the left-hand side equals right-hand side, and subtract. Uh-oh. Doesn't help that this class is right after lunch either. You're either starving or you just ate and now you're like, ugh. Okay. So, let's do a problem. Find the cubic polynomial P with real coefficients having zeros 3 and 2 plus I. Now remember what we're building up for here. We have, we know how to solve first degree linear problems, right? And we know how to solve quadratics. So when we go for third degree polynomial or higher, the way we attack them is, if I find a zero, I found a weak spot, right? Finding a zero is like, you have a third degree monster here, right? I can't defeat it. I can only throw first degree punches or first degree kicks, right? So I'm like, okay, you're third degree. So I say, oh, I found 1 0, kick him right in the knee, right? Then he comes down, he's on his knees. Now this third degree monster is a 2 degree monster. And I'm like, I won't tell you why I punched him. And now he's really hunched over. Ugh. Now can I solve a 1 degree polynomial? Yes. So I gotta find 3 ways to punch and kick this third degree monster to defeat it. I got 2 punches right here. How do I finish him off? It's a monster, all right. It's a math problem. Looks all mathy. So let's solve it. Now what I'm going to do with this chapter is, because it is the toughest chapter, you cannot just wait for me to give the answer and stare at the board, or you will fail. I promise you. This is the toughest chapter of them all. Now is the time where you do it. You do it with your neighbors. You ask questions. You don't leave here until you know how to do it. Because this is what happens with me when I was in college, and I was a professional college student. I was in college for 14 years. So I finally got my associates though, so that's good. Now I was undergrad for 4 and then a graduate student for 10 years. And you know, it's and you gotta remember, like, math, people say, well, you're just good at math, you just know math. No, I don't. Math is hard. Because the classes I'm taking were Math 900 at the U of A, you know, where it was like you have to invent your own math, dissertation. So math, I know what it's like for math to give me nightmares. I know what it's like to not know how to solve it. And I know what it's like to go to class and understand everything the teacher did on the board and get home and not understand anything. Because what I was doing in those lecture classes was just writing as fast as I could and not comprehending. So this is your time to comprehend. This is your time to do it. So I'm going to have you guys try to do it. Well, I'll get you guys started, okay? We need to find how many zeros? 3. I only got 2. How do I find the other one? I see some of you guys are phoning a friend. Going on Twitter. Okay, let me give you a hint. I just did something for you guys. What did I write here in the blue? 2 zeros for the price of 1. If this is a 0, then I have another 0, right? What is my other 0?
2 minus I.
2 minus I. I now have all 3 zeros. So what this means is that P of X is, now here's something you gotta be careful for. So the first one's gonna be X minus 3, right?
Yeah.
Be very careful here. If you do it this way, you won't mess up. Write X minus. Write it like this. It's always, always, always X minus something. Now if this was negative 3, it would be X plus 3, but it's secretly X minus negative 3, right? This is the 0. What goes here? 2 plus I, 2 minus I. The conjugate is in the parentheses here, not out here. Here's a second hint. This looks scary, right? Foil. Chew on some foil and it'll scare the monster away. You guys ever done that before? You guys want to try it? You guys never had like Halloween candy and you can leave it in your pocket and it gets all melted and you're like, I must eat my Nestle's Crunch melted bar. And you start picking it apart and there's a little piece of foil in there. Some of you guys know. Right? Sorry, trauma. Hint, foil the complex part first. If you do it right, if done correctly, the eyes disappear. I already see some of your eyes disappearing. I got jokes today. We're just getting started. I didn't say they were funny. I just said I got jokes. So what this means is foil this part first. I'm gonna give you guys a moment to do that. So just remember, foil, it's good to sometimes when it's crazy like this, kind of do each. I'll do the first one. X times X is X squared. You're welcome. Now you guys do the rest.
You don't have to distribute like the negative that's
Yep.
the minus.
No, well you can distribute. So if you want to, that's a good question. I could turn this into a trinomial times a trinomial, right? But I'm gonna think of it as like A minus B, you know, A minus C or something. That's a good point. So you could turn this into a, you know what, let's do it that way. This is really a three thing going on times a 3 thing. So let's distribute this. So this is X minus 2 minus I. Both ways are the same thing. You're gonna end up doing the same thing, but this might be less confusing. You guys see how I got this right here? So you guys can multiply this out. It's an almost foil. So I'm going to do X squared times minus 2X times, that's the first one. The second one, minus 2X plus 4 minus 2I
Plus 2.
right, and then minus plus 2. Oh wait, minus X minus 2I. What's minus I squared? It's gonna be plus 1, right? I times I is negative 1, but then this negative in front makes it positive. So see how I have 3 things times 3 things, I'm going to get 9 things when I'm done. And you might say, Morales, why on earth did you give me this hint? Because this is horrible. Did I mess up? Let me double check. I think I did it right. Oh, I did mess up somewhere.
Isn't it possible?
Where did I mess up?
In the third one?
This one right here? That should be plus 2I. I was just testing you guys. Or was I? So it was good to double check, which is what I just did. Now, let's see if my hint was worth anything. X squared, that's it, right?
Yeah.
2x, so this is 1, 2, that's the only, the minus 4x. Well, this is nice. I minus ix. So that's gone. And negative 2i plus 2i, that's gone. Plus 5. Well, that's a lot nicer, isn't it? So like I said, if you do it right, you get something nice like this. Now, just got to FOIL this out. Remember, this is the easy part of the problem. Foiling stuff out is easy because you just do it, right? Anti-foiling, which is like factoring, is the hard part. How do you go from, well, I'll talk about that in a moment. So now this is going to have 6 terms, right? Now remember the way I showed you guys last time? Did I show you guys last time? How you can do it this way?
Yeah, I think so.
So it's x squared minus 3x. Negative these two right here, plus 12x. And then minus 15. I'm just multiplying this by the negative 3. This is what you end up doing anyways, right? I'm going to take this negative 3 and then distribute it this way. Then I'm going to multiply by this next one, the x. So it's x cubed you guys see how I got these two numbers? Or these two lines? This is exactly what you would get if you were to go x cubed minus 4x squared plus 5. It's exactly that right there. Except now everything's nicely lined up. So, thus, we get x cubed I got really bad allergies right now. Plus 17x so this is our answer.
Where's the plus 2?
What plus 2?
Oh, never mind. Just kidding.
So the eyes will always disappear.
Yep. They don't disappear, you did it wrong. Now keep in mind, this is the easy part, which is still kind of complicated, but the thing is there was a path forward. It was tedious, it was ugly, but it was still just do it, right? Like if I said add, the first 100 numbers together, 1 plus 2 plus 3, that's tedious and horrible, but it's easy. You can do it, right? What we're gonna do now is the opposite. Go from here backwards. Let's use a different color. Go from here to here. So I'm going to say factor this. And you don't know that 3 is a 0. And you don't know that 2 plus I and 2 minus I are zeros. You have to find them. You see the challenge here? Then I do this thing where I said like factor two numbers last time. So let's say I say, let me get my calculator out. All right. Let's see how many of my students are posted on Facebook right now. Snapchat. All right. So if I were to say factor, I didn't do anything like this last time. Or was it my other class? Factor this number. See how long it takes you guys. You can use your calculators. You can use your calculators to do arithmetic, but you can't go on Google and say factor this. I'm trying to prove a point here. I'll give you guys a choice. No, I won't actually. I'm gonna torture you some more. Anyone? Factor this. Factor this right here. This is something that you can do in like 5th grade or something. Usually we're not doing such big numbers, but you learn to factor then, right? Like factor 6, 2 times 3, right? What's this? All right, no one's found the answer yet, right? Only half of you are looking for the answer. Now, what if I said this? Work this out. Tell me when you're done. How long does it take you guys to do this one?
2 seconds.
2 seconds. What's the answer?
15, 17.
Notice that this method took almost no time at all. How much longer did it take to factor? Now keep in mind, this is integers, numbers. This is arithmetic we're talking about. I'm trying to get you guys in the zone right here. When you multiply out, that's easy. When you factor and go the other way, it's way, way, way harder. Now if this easy part was hard, it's going to get even funner, don't worry. Now I'm not trying to discourage you guys, I'm just trying to get you guys like, take this seriously, all right? So, I know we just came back from spring break. I know we got people to text and have to, but you'll see when the test comes. Fundamental theorem of algebra. Remember, whenever something's called fundamental, it's pretty important. So it's basically saying every function, every polynomial of degree n greater than 1, greater than or equal to 1, has at least one complex zero. So what this means is there is at least one zero we can find to solve this. The number of zeros Degree n, we'll just write it in an easy way. Degree n means you have at most, you know what, I'm just going to jump right to it. You're going to have n zeros. So now we can find all this. Now some of them might be repeated, like we can have x minus 2 squared, and so 2 is of multiplicity 2. But here's what's going to happen now. If I give you a 4th degree polynomial, like for example, let's do something simple. X squared plus 1, not even equals 0. How do you factor that? You would normally say, I cannot factor it with real numbers. But with complex numbers, I can factor this like that, right? And now I have 2 zeros that popped out. Right? So with complex numbers, you get, if you have 3rd degree, you're going to get 3 zeros. If you have a 4th degree polynomial, you have to find all 4 degrees, all 4 zeros. You guys get what's going on here? I'll just keep going down here. Find all zeros. I hope I have enough ink to write this down. P of x. Now remember, we're going to uncharted territory. You know, how do you solve a 4th degree polynomial? I don't know. Well, I do know, but the answer is make your students do it. Where do we start on this problem? That's a good idea, but I'm going to give you guys, I'm going to be nice today. Actually, that's the correct right answer, Isabel. But I'm going to give you a hint. Given that, wouldn't it be nice if I gave you a 0? Because now this is going to turn into a 3rd degree, right? 1 minus I is a 0. So this should take about 5 or 10 minutes. I'll give you. I'll walk around. But I'll give you guys a hint. Let's just talk this out. We cannot solve 4th degree polynomial. We can only solve 1st degree and 2nd degree, right? But I have 2 zeros. I gave you 1, but I secretly gave you 2. It's like, you know, you marry a woman and for free her mother-in-law comes along, right? You got 2 women living in your house now instead of 1. So you have 2 zeros. With 2 zeros, that turns a 4th degree into a 2nd degree. And then can we solve 2nd degrees? Yep. So I can show you guys 2 ways to do this. I'll show you guys, well, I think some of you guys are doing this. So this is what I know for sure. I know for sure that this is going to be x, and to be careful I put it like this. I have 2 zeros, right? One of them is going to be 1 minus I. One of them is going to be 1 plus I, right? Times something. I don't know what that something is, right? But I know for sure that this goes into there, right? To find this something, I divide P of X by this. Now what is this? Is that the one we just did? We had a 2 in it? Well, it's the same process. So this is X squared, something, something else happens. X squared, I'm going to do it the way I was going to do it the first time. Minus X, 1 plus 1, I. Plus X, or minus X again. Ah, why is that so big? So X, see how I'm foiling it here? Outer, inner, last. Same process. I'm just doing it a different way so you don't see the same thing twice. The last time I just, but notice it's going to be the same thing because now I have to multiply this on the inside. Just another way of doing the same thing. So, X squared minus 2X minus IX plus IX. So that's gone. This is a difference of squares. This is going to be 1 plus 1 is 2 plus 2. Okay? So now, what does this tell me? This tells me that P of X, the original thing I had, is equal to this times whatever. I don't know what that whatever is. So how do I find that whatever?
Divide.
Divide. So now I got to scroll back up. So this is the analogy we have here, okay? The analogy we have here is 15, 17 equals 37 times something. Well, how do I find this something? Divide, right? So that's the analogy. So now I have to do polynomial division. Like, that's not what I was thinking of. Right? I'm gonna go to my 3-year-old son and be like, what's the first word that comes in your mouth? He's gonna say, Papa. I say, no, you idiot. Polynomial. So all right, so I'm gonna divide. Do you guys, are there any questions on what I'm doing so far? This was for free. This was given to us for free. Multiplying is tedious, but it's doable. Now to find what remains, I have to divide. Morales told me that one of the factors of 15, 17 was 37. How do I find the other one? Divide 15, 17 by 37. Well, now I have to divide here. And because I feel in a good mood today, I'm going to do this for you guys. Well, we're going to do it together. Like one big happy family. Smile. It's great being a math teacher. You know, like, walk into a classroom and people are forced to be there. They don't like the topic. Some of them are taking it again, so they really don't like it. And then this guy comes in. So I'm the one that's going to be imposing this math on you. So I'm already off to a great start. But don't kill the messenger, as they say. I'm bringing the good news. All right. X squared goes into x fourth how many times? X squared, right? I multiply this by everything here. I remember when I once taught algebra at the U of A, and I had a whole rugby team in my class. And I don't know if you guys know rugby folks. They tend to be very nice, young gentlemen, which is the exact opposite of what they are. First of all, how many of you guys in here play rugby? How many of you guys have brothers that play rugby?
What's
What-
rugby?
Exactly. What type of sport is rugby, right? Yeah, it's like a very aggressive football game, but for like usually richer folks, right? Like you guys never heard of it. So, you know. So imagine having a bunch of richer, aggressive
Entitled.
people who are in your algebra class, and if they don't pass, they don't play in the next game. That was fun. I was like, please put your newspaper down. They would just read it in front of you. At least you guys like text quietly, you know? So let's see. -7 plus 2 is minus 5x, and then 18 minus 2 is plus 16x squared. Now, I always just drop down everything. You can only drop down one, you can drop down everything. Might as well just drop it all down. If we're lucky, this will work out. So, x squared goes into this how many times?
5. 5x.
5x minus 5x, right? Now remember, our hope is when you keep everything lined up, it's all nice, and then when you know that once you get to the end here, you're done. This is minus 12. If we're lucky, now, how do I know I have to have a remainder of 0? Because these are zeros and this is a fact. So see how the zeros are related to the factors? This is a factor. Therefore, there better not be a remainder of 0.
There better not be a remainder?
There better not be, because then it's not a true factor. Right? If you, yeah. So if I do if I say 4 is a factor of 13, if I divide 4 into 13, I get 3 remainder 1. So therefore 4 is not a factor of 13, right?
So if we do have a remainder, it's not a 0.
It's not a 0.
So it's good if you do have a remainder.
No,
of 0?
you don't want a remainder of 0. The question is do we have to worry about that? Nope. Works out nicely.
Can you do this by using the synthetic division?
Kind of. You can't do this part using synthetic division because it's not a linear. Now, but that's a good question, Isabel. This is x squared?
That's it.
Oh yeah, I was having flashbacks on my rugby. Thank you. So now I know that this P of x I now know that this is equal to, whoa, this, this was just like a symbol for I don't know, right? I need help. Now I know that this is equal to x squared, what was it? Minus 5x plus 6. If there is a God and he hears our prayers, this will be factorable. Is it factorable?
Yes.
Yay! So x
Minus 2 minus.
Whoo-wee. So our zeros are therefore 2 and 3. So our answer is 2, 3, 1 plus or minus I. So it didn't really take that much. Well, it was, the first part was just the theorem. Now, so it took about this much, right? Now, is there an easier way to do this? Well, this actually isn't hard. It's all perspective, right? This way is a little messy, but it was straightforward. Because I had the two zeros, multiplied it out, did polynomial division, and that was easy to factor. Now, let's do another way. Based on a question Isabel asked. All right. So we're going to try this again. So turn your page over. Now, is there a way to do this in less than like 3 pages of paper? Well, what is the first thing? So remember what I said? The act of knocking down this monster, this punch, is synthetic division, right? So I know that 1 minus I is a 0. Therefore, if there's any justice in this world, this will divide into this right here. One minus 7. Now leave a little bit more space than you used to, because we're going to have 2 numbers here now, because we're going to be doing complex. Now this looks a little scary, but it's actually, you're going to see this is actually very straightforward and simple. Let's do it. Ready? 1. I'll do the first one, you guys do the rest. Just joking. 1 times this is 1 minus I. No big deal. Now what I'm going to do is actually I'm going to line these up to make the math easier. So 1 minus I. Okay, so now it's easy to do the math. This is going to be negative 6 minus I. Now also make sure that you're not confusing, make sure there's space here. Now what is this times this? We can use our calculators, remember? So I'm not really afraid of these types of problems. I could put this in my calculator. 1 minus I times negative 6 minus I. So negative 7 plus 5I. Well, I might as well just keep going. Plus 18. Well, let me at least write this down. So minus 7 plus 5i. Minus 7 plus 5i. Well, that I can do. That's 11 plus 5i. So now look, I have that number still there, right? Plus 18, right? I'm doing the whole synthetic division on my calculator. Times 1 minus I. 16 minus 6i. So this ain't so bad, right? 16 minus 6i. So minus 22, that's going to be minus 6. Ooh, look at that. There's a light at the end of the tunnel. And for once, it isn't a train coming right at us. This times you guys see that? What? Oh my God. So guess what? This looks horrible, right? Except for one thing, I got my next zero all lined up. One plus I. Now it's a little messy, but our calculators do it all for us, right? So sometimes you can do it in your head really quickly. I'll let you guys use your calculators to catch up. Well, you guys can just copy this down too, because you guys know the process now, right? Now notice what I get right here. So let's look at how much work we did. We did synthetic division once. We did synthetic division twice. That's 2 steps. At this step, I say, yay, I am happy because I know how to solve all quadratic functions, especially those that are factorable. I'm done. Done. So remember I told you it's doable in like in 2 or 3 steps? I wasn't lying. What tripped some of you guys up was you saw a complex and you're like, I can't do synthetic with complex, right? So it must be, but it's exactly the same as everything else we've done. Give me a 0 and I'll do synthetic division. Any questions? This one, so I don't run out of ink, I'm going to type it out. Plus my handwriting is horrible.
You can also solve it without doing those two, right?
What do you mean?
Because we solved it by graphing it and we got the same zeros without doing all of that.
So the way this problem would be on a test, so that's good. That's really good. On a test, I would do that. So Isabel was able to solve this problem in like 30 seconds. She graphed it and found 3 and 2 on the x-intercepts. Now, the way I would change it on the test is I would give you 3 and 2, or you'd have to find it real easily, but then you'd have to find the 1 plus I, 1 minus I.
How would you find
You'd have to do synthetic division twice, and then you would quadratic formula this. And you can get I's
So
with
it would be like the x minus 2 and then divide it into the...
if let's say I gave you this problem just cold like that on the test, and I gave you no zeros, the first thing you would want to do is see, you would graph it. Once you graph it, you're going to find 2 very easy zeros, 3 and 2. So you would do synthetic division 3, and then synthetic division 2. And then what you get here is a quadratic, and you'll get 1 plus I, 1 minus I when you work it all out. Question?
I just have one. How do you know how many zeros is going to be? Question.
Number of zeros theorem. How many? What's the degree? That's the number of zeros. So what's the degree here? 4. So we're gonna have 4 zeros. Yeah, that's how you know when to stop, right? Otherwise, you keep going. And 4 zeros means, well, 4th degree means 4 zeros. Now, let's see if I can write this without laughing too much. Find a this didn't even last. Find a polynomial with real coefficients. That means, you know, nothing crazy. Of least possible degree, having a 0, 2 of multiplicity 3, a 0, 0 of multiplicity 2, and a 0 I of single multiplicity. Now I laugh because it's going to be a big polynomial. I like to torture my students. But this is actually a very, very easy problem. It just looks scary. Here's a hint, it's more than degree 5. Here's a hint, it's more than degree 6. No more hints. Could be degree 17. I don't know. I forgot. Well, I'm telling you though, this is a very, very easy question if you understand it. I wouldn't mind asking something like this on a test because it is so easy. When you see me do it, you're going to say, that's it.
What does multiplicity mean?
Multiplicity means, like if you have x minus 2, like cubed, it's a 0 of 2 with multiplicity 3.
Oh, okay.
It's the 2 is repeated 3 times. I'm done torturing you guys. Let's just do this. P of x is, let's go through this. 0, 2, that means x minus 2 of multiplicity 3 means that. a 0, 0, so that means x minus 0, which is just x of multiplicity 2, and a 0 of I of single multiplicity, which means just 1. So I'm done? If I have a 0 of I must have a 0 of x plus I.
Multiply it all out.
Then you multiply it all out, which you think might look hard, but it's actually not very hard. And I'll just give you the answer. Because it just takes some time to do it. Now, questions on tests that I give, I usually don't try to be too tricky. Like I try to, like it's a test, I'm not gonna be too mean. Like it's something you should be able to do in a few minutes, right? So what if I ask this question on the test? Now, like I said, you're gonna have to still multiply, FOIL, and all this stuff, but you're gonna get this in the end. What if I ask this question on the test? If I said, factor this. So let's think about it like that. Let's say this was a test question, but you didn't know what I just told you. You obviously know how to factor it, right? Because we just factored it. How would you go about this? Start with an x squared, right? Well, that x squared, when I factor it out, it's already going to give me, look, I'm already on the way, right? So, and then you find the two. Well, let's explore this. Let's do this. Let's pretend we didn't know any zeros. So right away, I'm able to knock this down to a 5th degree. You're just a 5th degree black belt. Psh, that's nothing. Yeah, right. Plus 13. So already we knocked this down a few levels. This is a 1. So I'm not even worrying about this x squared anymore. It's just kind of just there hanging out, right? So now I'm just worried about this. This is kind of how you go through life, right? It's like, how do you get a bachelor's degree? I don't know if I can ever do it. How do you get a master's degree? I don't know. How do you get a medical degree? You know how you do it? Just little step by step. Get it taken out of the way. Now it's a little bit easier. All of you guys are going to be closer. Well, hopefully all you guys are going to be closer to your college degrees after taking this class, right? This class is the x squared. That's a little brutal. But once you're done with it, the way to gain your degree is a little bit easier. And then now that you know algebra, you're going to be like, psh, it's all easy, right? Like, take a Shakespeare class and just say, you know, I'll factor any 7th degree polynomial you give me. It's all math, even Shakespeare. Iambic pentameter, right? It's all math. What's iambic pentameter? Come on, the math teacher can't know what this is. What is iambic pentameter?
It's the poem something, right? It's the beat to the thing.
Isn't it like what Shakespeare does?
Same.
See how I just went in a circle? It's not singing. All right. So see, if I can know more than math, you guys can know math, right? So, because I have students that will say, well, if you give me something to write, I'll write it. But I just asked a literature question. What's a gerund? What's a gerund? Name, Gerald. Gerald Ford was president. President Gerald Ford. What is a gerund? Like this jury is adjourned? No. This is a very basic grammar question. You guys know what a verb is?
Yeah, it's a form of a verb when it functions grammatically as a noun is a sentence.
Yep. It's a form of a verb where it's tense. What do you say? No, this is something that we use all the time. You guys ever done those things back in elementary school where you break apart a sentence like this is a noun, this is the verb? Well, the gerund means it basically means ing. A farm is a noun, right? But if I say I'm farming, and I'll turn it into a verb because I'm doing something, but that's a gerund because it comes from an. Anyways, whatever. What do I do now? How do I find the next zeros?
Graph.
Graph it, right? And what are you going to find? You're going to find that 2 is a 0. And so then you're going to do 2 synthetic division. And then you're going to graph what remains, and you're going to find, oh, 2 once again. And then when you're done with that, you're going to find 2 once again. By now you have a second degree polynomial. I don't want to do it all because you guys can graph it. It's going to take a while to graph and stuff. But by this time, I'm going to have something like x squared plus 1 equals 0. And then I'm done.
You keep dividing it by x squared, x squared, x squared?
No, you keep dividing by 2.
But how did you get that too?
You graph it, and you're going to find a 2. Then you graph this, and you're going to find 2 again. And then you're going to graph this, and you're going to say 2's yet again, and 2 is still 0. And then when you're done with your synthetic division, you're going to have 1, 0, 1, 0. And that's just
So you
this.
graph it inside the division table?
Yep. So first you would graph this. So notice I'm not graphing the original 7th degree polynomial. I'm graphing the 5th degree. Once I knock it down a level, I graph the 4th degree. And then I graph the 3rd degree. Once I graph it again, it's gonna look like this. And there's no zeros there. But that's just that right there. You guys want to try it? I mean, I'll just.
So you have to graph the first.
Let's do it twice. Graph this. This is a good question because I might ask this same exact question on the test.
So when
I've been known
you
to do that.
synthetic division, you would put what we graphed on the bottom.
How about this? You guys graph and I'll do the synthetic division. Is that fair? I think it's fair. So, these are really good questions. One, negative, because I might ask this question on the test, like I said. So I'm going to do synthetic division. You guys graphed it, and you found that 2 was a 0. So I'm saying, okay, well, you do that part, I'll do this part. Uh-oh. Psych. So what happened here? Oh, I see what happened. You guys see the error? Right there. Did I mess up again? Man. 4 times that is 8. That's 20. This is a 0, right? Oh. No, it is. It's 0. 10, 14. 18 minus 4. And then 4 times 8 is 12. Question or go.
Shouldn't the first two at the bottom be one?
Yup. Now the reason I don't mind doing this stuff on the fly is because notice that I was wrong, but it's important to know that you're wrong. Okay, so I didn't like just like scribble it out and say whatever, I'm right, you're wrong. If you ever have a teacher that does that, they don't know what they're doing. So knowing you're wrong is important. Tell that to your spouse, right? How did I know it was wrong? Because the last number wasn't 0, right? So I knew I had to have messed up somewhere. Now it's minus 8. Now it's all nice. So then what you would do, we won't do this again. Then you would graph this, or unless you guys want to. You graph this, and you're gonna find, oh, 2 once again is a, well, I might as well do it because we already know it's gonna be 2, 2, 2, and 2, right? I already got us started down this path, so. One is the first number. 2. Remember I told you guys you're going to be doing synthetic division a lot in this chapter. I wasn't lying. 0. Now, I would actually do something else at this point. You know what I would do? You see how these numbers repeat? I would, at this point, stop with the procedure. And I would say, wait a second. Hold on a second. I know how to solve this. It's a plus, so that's a plus. Aha! There is yet another 0 that is a 2, and then the x squared plus 9. I might just ask this question on the test. Because I already solved it for you guys like 10 different ways. One of them was right. So, suffice it to say, going forward was easy. Going backwards is harder. But graphing makes it easier because then I can just pull these numbers out right here. I'm going to graph it, see a 2. I'm going to graph it, see a 2. I'm going to graph it, see a 2. When I do synthetic division, the I and the negative I come out. And by the eyes come out, I don't mean like you're so tired you just start. Just I'm done. I don't want to see this anymore. Well, the answer is this up here. If we factored it, the question would probably be factor, or it would be find the zeros. So we would have 0, we have 2, 2, 2, I, negative I, and then the 0, 0 from here. So maybe I'll have something like this that's worth about 40 points in the test.
So you know how it says x minus 2, and it's like positive when you put it into negative position?
It's because the 0, this means x equals 2, right? And the 0 is what you put right here. So when you're dividing by x minus c, that's why it's a little confusing, because you have the positive and the negative. But wait, there's more. Let's take a 5-minute break so you guys can go scream at the sky. Don't worry, I'll have some harder problems when we come back.
Okay.